Hello everyone, we're looking at an example of a distance equals rate times time. As the first step, we're going to read it aloud. It says a freight train and a passenger left the train station at the same time. The trains traveled in opposite directions, okay? So you already know that in your picture, two things are kind of going apart, right? The passenger train traveled 20 kilometers per hour faster than the freight train, okay? So one of these is the passenger train. It's traveling faster, so I'm going to call this the passenger. And this is going to be the freight train here. After 10 hours, so that's the time, they were 900 kilometers apart. Find the speed of the freight train. So I really want to find the rate of the freight train. But before I do that, each of my arrows get their respective distance equals rate times time. Okay. Now I just fill in what I know. So they left the train station at the same time, okay, and then so that t is going to stay as t basically, unless they give us the time. So the trains traveled in opposite directions. I already have that here in my picture. The passenger train traveled 20 miles an hour faster, so that means more so than the freight train. So if he's going faster, the passenger train, his rate is going to be 20 more than the freight train's rate. So that remains as R. After 10 hours, so that's T. And remember, T is time. And so the times are the same. So you can just leave this as T, but actually you know how much time. They're saying after 10, so then 10 is going to go inside here for each one, right? So then we have R times 10, and then, because these are different, right? And then you have 10 times R plus 20, and then after 10 hours they were 900 kilometers apart, right? So what does this mean? So this means that the entire distance, so from here to here, this is 900, okay? So if you remember what we talked about in class, and each of these have their own respective D's, so if this whole thing is 900, we can call, let's just say, this leg of the journey from here to here, from where they started to where the passenger train was, let's just call this D1. So therefore, the remainder of this is 900 minus D1. Okay? So that means that this distance here is 900 minus D1, and this distance here is just, from here to here, is just D1. So then, this is equal to D1. Can't really see. But we have D1 equals 10 times the quantity of R plus 20. And now what do we do? Well, we just use substitution. What you're going to do, you're going to plug this thing into here. Okay. And you get 900 minus the quantity of 10 times R plus 20 equals R times 10. So what we're going to get is negative 900 minus, is it going to be 10R plus 200 equals 10R. So 900 minus 10R minus 200 equals 10R. I'm going to add 10R to both sides. So I'm going to have 900 minus 200 is equal to 20R. And a 900 minus 200, I believe, is 700. And now we divide by 20. And so the rate, remember, because R was, who was R? Well, R is just the rate of the freight train. It's going to be, over here, we have 700 over 20 is just 70 over 2, and half of that is 35. And so that is the R of who, that was the freight train, and that's what I wanted to find, is the freight train speed. So we can clearly see it is 35.